Hello, my name is Braden Whitcher, and this is my code review for CS-499 at Southern New Hampshire University. So I'm first going to start off the code review by first explaining my project, kind of why I chose it, and the current state that it's in. So the project that I chose is a Unix-based shell that will be able to list the files of the current working directory, change your directory, print the history of the commands that you used, save aliases to a database, and potentially more depending on how much time I have to develop them. The reason why I say quote unquote will be able to is because I just started the rough draft for it, and there's still a lot to work on to do on it. So since I chose my own project, I didn't have any source code to start off with. So I was given the option to either create the code myself for the code review or do it on an open source project. The reason why I chose to quickly come up with something myself to do the code review on is because I don't want to review kind of any other solution to any other shells. This is kind of how I like um, this is kind of how I like to do projects. I first understand the tool that I want to build, rather if it's a shell, a game engine, a terminal, a code editor, it doesn't really matter. Then once I'm done creating my own solution, that's when I'll look up other solutions uh, because it kind of allows me to see how other people do things, and so I can kind of look at certain features and compare my solution to it versus theirs. And so kind of doing that, I find that really intriguing because it kind of lets me know how other people think, how other people do things. um, and the reason why I chose to create my own project that I haven't done in my degree program before is because I really like low level programming, and we really haven't done a whole lot of that in the program. I really like learning how things work at a low level. And I like to understand how data structures and algorithms work from low level programming because I think that they're super important to know and understand how to do. So now we'll first look at the first category, which is software design and engineering. So this is just kind of my whole project here. It's just about 180, roughly 185 lines long, but the kind of the first part of it is I have a linked list defined, just right up here at the very beginning, and then it goes into the main function, which is essentially just a REPL program, which is read, evaluate, print, and loop. And so it starts off with this infinite loop here and a kind of a target string to where if the user enters in quit, then it exits out of the infinite loop. It looks for a line, um, and then kind of it compares what the user entered to the built-in commands that are entered in here. And so, if ls is entered, then it executes all this functionality down here. If cd is entered, enters in kind of, or it executes this block of code. If history is entered, you kind of get it. And then if none of the built-in commands are entered, then it just prints this is not a built-in command. And so I can kind of demonstrate the current working state of it right now. And so if I type in ls, then it currently lists the files of my current working directory, which is essentially just this file right here because this is the file that the executable is in. And so it just tested or just listed everything that's in this file right here. CD currently doesn't work. I currently don't have the functionality implemented right now. But if I do type in history, then this kind of lists a fixed size array of the history, which appends everything to the front of the array. And so if I type in ls again, then history, as you can see, ls is entered in first, and then cd is pushed to the back there. And then if I type in alias, which is the other built-in command right down here, alias, and then some other stuff here, just some random gibberish, then it tokenizes this input. So for the first tokenization is trying to identify, if the first word entered was alias. If it is, then every other string after that, there should only be two. Then it kind of tokenizes that. And so yeah, that's kind of my whole project right now, and kind of the current working state that it's in. And so the first enhancement that I'm going to make in this category is by separating the functionality in the main.c file into separate files to kind of clean it up and make it more readable. Each file will obviously have their own functions that will be called in the main file. So because everything is kind of jumbled up mess, in this main.c file, I do have history.c, which is just a basic loop that or basic function that takes in an array of strings and just loops through them and then prints each one. That's the only other separate file that I have. And so kind of like this this linked list implementation right here, all of these functions will be separated into their own linked list file. This main loop I'll probably separate into its own file, and then each functionality, like checking to see if the user command started with cd, or if the user command is history or alias or ls, those I may separate into their own files and kind of have their own functionality of it. But I would say that's the main enhancement that I want to make first, is just cleaning this up, separating them into each files, making it much more readable. And then the second enhancement I'll make is documenting and commenting the code a lot more frequently and more detailed. I kind of have some comments sprinkled around here and there, but really not enough to really accurately explain what the code does to someone who has never seen the code base before. So yeah, I kind of have main comments, like this one's kind of useless, struct value for key value map to pointer to next. If for anyone that understands and codes C, that's pretty obvious right there. Dynamically allocates memory for linked list. Kind of check to see if the user input is equal to quit. Like, okay, but I would say that I definitely need to include a lot more comments, especially for stuff like this tokenization, because I have one comment that explains the overall functionality of it, but nothing about the internal functionality of it, if that makes any sense. But now I guess we'll move on to the second category, which is data structures and algorithms. And so if I scroll down to the implementation, which is just right here, these small little functionality right here. So in the assignment for module 1, I explained that I was going to use a linked list to store the history of commands that the user entered. For my current implementation, however, I just use a fixed size array that essentially just appends certain commands to the beginning of it when the user types them in. And so I kind of showed that functionality earlier, but this is essentially what that does. It first checks to see if the first element in the array is null. If it is, then it just appends it to that first spot. However, if it isn't, then it switches the string in the first spot to the second spot, and then puts the current string in the first spot. And so the main problem with this is it's a fixed size array, and so obviously in a normal shell, I'm not gonna know how many commands a user entered, and so I can make it a fixed size of like 50 and just hope that the user doesn't go over 50, but I'd say that's a pretty big hope factor. But because I currently don't know what the average command or the average number of commands that the user typically enters in. But for some reason, if it does go over 50, then that could be a big problem in my program. And the second main problem with this is that it only checks against the built-in commands. And so obviously in a normal terminal, so like if I go to my terminal, which I use iterm, oh gosh, never mind. I don't want to update it right now. But if I type in some gibberish like this, obviously, oh, there's another bug I have, but anyway. So if I type in something like that, this is not a built-in command. That's not gonna append it to that history because it's not in this array of built-in commands up here, and so that's something that I definitely have to fix with the linked list. Is that no matter if it's a built-in command or not, it's still gonna append that to the linked list. And another benefit of using the linked list is that it's able to dynamically allocate memory. So it doesn't matter how many commands the user enters in, it's going to grow with it no matter how large it goes. I assume that it's not going to become very large, but it's still going to kind of grow with the number of commands that the user enters. So yeah, that's the data structure and implementation for it. And so now let's move on to the final category, which is database implementation, which is going to be right down here in this little functionality here. And so the current code that I have for this is essentially a simple function that tokenizes the user input whenever the first string of characters matches the word lias and stores them in a separate array where each word that has a space in between is its own element in the array. So I was going to implement, or I was going to also store these tokenized strings into a linked list, which you obviously saw the implementation for it right up here. But it turns out that I kind of started to run out of time and didn't want to keep stretching out this rough draft longer than it needed to be, and I didn't want to do too much to where I end up doing a large majority of the project just in this week. And so but that doesn't mean that I wasted my time on the linked list, because I'm going to use it for the data structures and algorithms category for the history of commands. So the enhancement I'm going to make for this section is to implement an SQLite database that stores an alias as a key value pair, which is also essentially a hash map, into its own table. And so the reason why I chose SQLite is because it's serverless, which means that no network connection is required to fetch data from it. The reason how it's able to do this is because it really is just essentially just a file that gets stored on your local computer, on your computer's disk. Hey, sorry, those are my cats. So those are the current state of each category and the enhancements I'm going to make to them. I'm also going to implement more functionality that will make this project feel much more like a shell, kind of which I mentioned earlier, which is to implement the functionality for changing the current working directory with the cd command, being able to create a text file and having the ability to write to it, and potentially more, such as piping and jobs, kind of if I have the time for them. So now I guess we'll go into the code review checklist and see which areas I have implemented well and which ones that I definitely need to work on. So the first one is, does the code completely incorrectly implement the design? So kind of, the overall project has the similar functionality to a shell, but kind of if we break down each category, the built-in commands, yes, ls actually works. That actually does print the current working directory and the files in them. But as far as the database implementation, this doesn't really do the functionality that I wanted to do, which is to implement the SQLite database. And plus I kind of explained how this fixed sized I meant the commands up here, but I kind of mentioned earlier that the fixed size array is very inefficient because it's only currently able to store up to 3 different strings, which obviously I'm not going to know how many commands that the user enters, and so that's just very inefficient. And then with the database implementation, this doesn't store anything. It just tokenizes it, and then I guess it does store those tokenized strings into this separate kind of token array. But as far as fetching fetching the ELISAs and using them, it doesn't have any implementation like that. So that definitely doesn't completely and correctly implement the design that I want. And so the next one is a code well structured, consistent in style, and consistently formatted? Yeah, I would say it's everything has equal white space, everything has equal indentation. Um, every all the functions are have the names or the same naming convention. So I would say everything is pretty consistent as far as just kind of setting the functionality aside. Everything is pretty readable. There's no really inconsistency. And so I'd say for that area, I'd say it's pretty correctly implemented. Um, does the code conform to any pertinent coding standards? Um, I would say if this was in if I was working in a company and came up with this, that it just kind of depends on their coding standards. For my coding standards, I would say yes, just because I really don't have a strict style of coding standards, but like this implementation probably wouldn't be fine in a company setting or a work setting, and so I would say yes and no for that checklist there. Um, so moving on to the documentation portion of the checklist. Is the code clearly and adequately documented with an easy to maintain commenting style? Not really. It's not really documented very well. Like I said earlier, I kind of have comments sprinkled here and there. Infinite loop, one right here. These just kind of explain each command that the user enters and what it does. But I still think that if someone brand new were to jump in and look at this code base, I think it would take them a hot minute to kind of understand what's all going on. And so that's kind of relevant to all three categories, is that I could definitely take more time to comment out and document what each one does, especially kind of for this linked list here. Um, kind of for like these up here, how this is array for built-in commands. This dynamically allocates memory for the user command, command history, and so I could definitely document a lot more and more frequently, and especially with the comments as well. Are all variables? I don't know. Yeah, are all variables properly defined with meaningful, consistent, and clear names? Yes, partially. There is one, this variable here, Boolean value, that is obviously a very inefficient naming style. To name a Boolean value, I could do better and name that something like is built-in command, or something like that, because that's essentially what this Boolean value does, is that for each command that the user enters that is a built-in command, then it turns this Boolean value into true, so that way it doesn't print this statement. Because if I don't do that, then let's say up here in the string fans, if the user enters CD, then when it checks against these two, it's gonna say not a built-in command for this one, not a built-in command for this one, but then execute the functionality for this one. And so that's kind of why I have this at the very end, is that once it goes through the whole list of commands, if that Boolean value is still false, then it prints this command. And so I'll definitely change that variable to something a lot more meaningful. But as far as I know, that's pretty much the only variable that I can think of that really has a bad naming convention to it. So yeah. And then, are there any redundant or unused variables. Um, Unused variables, no. I think every single variable that I've defined is being used well, and I know of that because I'm using C-line as my IDE, and so if I were to have any unused variables, then they would kind of be grayed out and maybe even have like a yellow squiggly line underneath them. But yeah, as far as I don't know, all my variables are being used properly, which is good. And so, as for the arithmetic operations section of the code review, there currently is none, and I'm not really sure if there ever will be. There might be if the project gets complex enough, kind of if I'm able to grow it big enough like that. But the current version and the current vision that I have for it is that it probably will not include any type of arithmetic operations. So going to the next one, we're going to move on to loops and branches section. Are all loops, branches, and logic constructs complete, correct, and properly nested? I would say yes, because kind of the for and if loops kind of start right down here in the main function. The for loop for the infinite loop, everything inside here is indented correctly. So if I kind of go down here, this is where it ends. So yeah, everything's indented in between, and then it starts off with these if statements in between that checks against the user command. So this checks to see if the user command is quit, breaks out of the whole while loop. Else, if that isn't, and then everything is kind of nested here in this else, which is all properly formatted and nested, and then defines a Boolean value, defines another for loop. This checks to basically checks against the size of the built-in array list, which is up here. It's 4, and so this is what if I equals 0, if I is less than 4, then it checks to see against each command, each built-in command that the user enters. And so yes, everything, all the for loops and if loops are all properly nested, properly formatted, kind of in all 3 areas here. So that's pretty well done. Are loop termination conditions obviously invariably achievable? Yes. So to break out of this infinite loop, like I mentioned earlier, it checks to see right here if the string is equal to quit to break out of it, and does that right here, breaks it. And then even down here, it checks against each kind of else or if block, checks to see if the user command is currently a built-in command. If it is, executes some sort of functionality, and then right at the very end, it breaks out of it. And so this kind of breaks out the whole while loop, and I can also kind of demonstrate, or not, this doesn't break out the whole while loop, it just breaks out of the current I guess if block, and then goes back up to the while block to take in more commands. So type in ls, type in history. Yeah, that's what I mean. It kind of allows me to keep entering commands, but then when I type in quit, then it finishes with xcode 0, which means it ended the program. And so yes, that does work properly. Now the last section on the checklist is defensive programming. So is every memory allocation deallocated? Yes and no. So I know this command up here, this is the variable that stores the user command, and so it uses the malloc to dynamically allocate memory to it, and so that is deallocated down here. I even included a comment for it. But as far as where is it? This function, or this function right here, this stirred up function, I'm pretty sure that like under the hood that dynamically allocates memory to it. So I think this I have to deallocate the memory, but I kind of have to double check on that, but I'm pretty sure that's what it does. And so that may be a spot where I have incorrectly deallocated the memory, and so that's going to cause some trouble in the future, obviously, with memory leaks. And then the other implementation that I have for it is in the linked list up here. And so I used malloc to dynamically allocate array or memory for the creating the list, and then these also use the stringed up functions as well. And then I have a whole separate function that frees the entire list. Frees the key value and then the kind of the whole node, and then also frees the whole list as well. And so that will also be called kind of at the very end as well, because if I obviously free up or deallocate the memory earlier in the code, kind of first when the linked list gets created for the aliases, then or for the history of commands, then that's obviously going to lose the values that I put in it, and so it's not going to correctly store it, and then it's not going to correctly print out all of them, and so all that needs to be deallocated just at the very end of this program when it breaks out of this infinite loop. And so our indexes, pointers, and subscripts tested against array, record, or file bounds. File bounds, I guess it kind of is tested against it because, like I said earlier, this commands built-in array has 4 strings in it, and so the for loop down here will only go up, will only go up to 4 items. So that's not gonna go out of bounds or anything like that. I'm pretty sure that's the only spot where I have it. So yeah, I guess that kind of does it, but I mean, I still could implement kind of an else statement to the safe statement right here. Kind of right here would be like, else, and then right in here would be like, if the file is out of bounds, kind of let that user know so that it just doesn't give, a random red error that the user won't be able to understand about it. And then I guess another thing that I just saw right here is, oh, never mind. I forgot what I was going to say. But anyway, so yeah, that's kind of my whole entire project. That's all the enhancements that I'm going to make to each section, and how I'm just gonna keep working on it, making it better. I'm really excited about this project, and I can't wait to see what it ends up being. So thank you for your time. Have a good day.